Hey everybody, hope you all enjoyed last week the function notation and polynomials and adding, subtracting, multiplying, dividing, evaluating, and composition. It was a lot. So make sure you still got that down. Look at your quiz. If you got questions over it, want to go over it with me, please set up a time, let me know, and I will be glad to do that. This week we're going to look at inverses today, kind of proving inverses are inverses tomorrow. And then we're going to start talking about what is a polynomial again and defining it and labeling it and all that stuff on Wednesday. And then Thursday, we will be looking at our binomial expansion. So no quiz or anything this week, but we'll get into it. So talking about inverses, what is an inverse? An inverse function interchanges the input, and the input is our x. So it interchanges the input and the output, which is our y, values of an original equation. You'll also see it written as domain and range. So domain is your x, range is your y. So pretty much your domain is your x, your range is your y. Domain is your x, range is your y. So we're going to interchange them. So the domain becomes the range, and the range becomes the domain. So the inverse function of f is denoted by f of x is going to change to f inverse of x. So this is your original, this is the inverse. So -1 is not an exponent, it's a notation. So it's not f to the -1 power, it's f inverse. So keep that straight. So what is the main thing you need to remember with inverses? Oh man, I can't spell. I started spelling my last name. Switch your x's and your y's, and then solve for x. So if I'm looking at this, a couple easy ones to start with. Let's find the inverse of each relation. So a relation is a group of points. So my inverse here, all I'm gonna do, here's my x, here's my y. I don't know why it's going crazy, but I'm gonna switch those. So I got my bracket, so I got 2, 1 is gonna be my new point here. 4, 2, 6, 3, 8, 4. All you're doing is switching your x and your y, and you get the inverse of that relation. It's the same thing if I come over here to b. I'm going to switch my x and y. So I got 4, -2. You notice the signs go with the number. The number stays how it is. The signs don't stay. So kind of looking at that, you got your inverse. Now let's find the inverse functions from a graph. It's the same thing. I'm going to take my point, my new points here. If I want to list them, you can see them. I'm going to flip them. So -2, -4, 0, -3, 1, -1. Going up the list, so 0, 3 becomes 3, 0, and then 4, 4 stays. So if I plot these points, you can see these. So -2, 1, 2, -1, 2, 3, 4 is down about here. It's a little off the graph, but it's okay. 0, -1, 2, 3. And then I get 1, -1, so it's here. Then I have 3, 0, which is here. And I'm at 4, 4 here. So if I connect these dots, you can see this is my inverse right here. The orange is my inverse. Cool thing about inverses is they are symmetric about the line y equals x. So if I graph the line y equals x, so it starts at 0, 0, my slope is up 1 over 1, up 1 over 1, and I fold the black line over that blue dashed line, I get the orange line. Pretty cool. Symmetry. Love it. All right. Let's look at a actual graph. So if I graph my line y equals x, so start at 0, 0, go up 1 over 1. I got my symmetry. That's kind of where I'm going to go. So I'm going to look at exact points. So this is -3, 0. I just like to list them. So 0, -3 would be a new point. -2, 1. So that becomes 1, -2. Here's another exact point. So that is 1, 2. So that becomes 2, 1. Those are all the exact points, but that's enough, I think, to graph it. So 0, -1, 2, 3. So down here somewhere. Close enough. 1, -2, so 1, -1, 2. So here, this one becomes 1, 2, 1. So you can kind of see your sketch, and you can kind of see how it is a good reflection over it. So now, go back and plot your, whatever, we did that. I got ahead of myself. So, you people that like to fill in all the gaps, we plotted our points. I get in the habit of just rolling. It is a reflection of y equals x. All right, inverse is explained. So first, let's start with a basic equation. So g of x, we can also call that y if we want to. If I were to substitute in a value for x, then what is the order of steps I would do to follow the equation? So if I wanted to substitute it in, what would I do? So on and so forth. So if I take this, I have, well, you can kind of think of that. I'm just going to go ahead and do it. So I have, if I switch x and y, I now get x equals y cubed minus 9. So this is how inverses go. I switch at my x and my y, and now I just want to solve for my y to get it back. So what's the first thing I have to do? I have to add 9 to both sides, because that's going to allow me to isolate the y. Okay? So if I'm looking at this, I'm going to isolate that y. And then now if I come over here, now I can undo that cube. So I can take the cubed root of both sides. So y equals the cubed root, I'm undoing the cube, sorry, of x plus 9. So then I can go back, proper notation, this was g of x. So g inverse of x, it's going to be x cubed plus 9. So if I look at these steps, kind of here, I have a cube and then I subtract 9, so I'm kind of undoing everything and working from that. So inverses, inverses, inverses. So what we're going to do here, I'll work this long one out. Actually, I'll just work them out. If you want it broken down with actual steps written out, like add 2, square root, multiply by 2, and all that stuff, pull up the notes. They'll go through that. I'm just going to solve these to kind of work through them. So what I'm going to do here, I'm going to rewrite it. So y equals 2 times the square root of x plus 2. So I'm going to switch x and y. Nothing changes besides that. And now, I gotta learn my processes, so I have to solve this equation for y. So first thing I wanna do is, let's divide everything by 2, because I want to isolate this. That's gotta get by itself. So I have x over 2 equals the square root of y plus 2. Now that's isolated, so I can square both sides. Excuse me. So I got x divided by 2 squared is equal to y plus 2. Now I can subtract 2. I don't want to add them, I want to subtract them. So minus 2 from both sides. So y is going to equal x squared over 2. Sorry, the square is on the outside. X over 2 squared minus 2. I can leave it like that. So now f inverse of x is equal to x over 2 squared minus 2. Or if you wanted to multiply that out, you could. So x squared over 4 minus 2. And those would be my inverses. So writing an inverse is what we're going to do today. All right, let's look at B. So I got y equals x minus 4 squared. I'm going to go ahead and switch x and y. So x equals y minus 4 squared. So learning my order of operations again. The whole thing is in parentheses, so I can actually go ahead and take the square root of both sides. So I have the square root of x is equal to y minus 4. Now I can get the y by itself. So square root of x plus 4 is equal to y. So now I can rewrite it f inverse of x is equal to the square root of x plus 4. And the 4 is on the outside, it does not go on the inside. Once we get this down, we'll talk about domain restrictions later. But for now, I just want to make sure we got the process down. All right, so I got y equals 2x minus 7. Switch x and y. Now let's solve for y. So add 7 to both sides. So x plus 7 equals 2y. Now divide everything by 2. So y equals x plus 7 over 2. And just rewrite it. So f inverse of x. And your y should disappear when you're done, because you're rewriting f inverse of x instead of y to denote that that is your inverse. All right. If you need me to break down step by step, please let me know. So here, a little bit more complicated. So y equals 5x plus 9 divided by 6. Let's go ahead and switch it. Now, I have to get the y by itself. So I put that over 1 so I can cross multiply. So 6x equals 5y plus 9. That allows me to get everything on one row. It's a quick, easy technique. So let's go to the next color. Let's subtract 9 from both sides. So 6x minus 9 equals 5y. Divide everything by 5. So y is going to equal 6x minus 9, and everything is divided by 5. So the inverse of f of x is equal to 6x minus 9 over 5. All right. You can take a while. You can look at these, practice them. It's the same thing. If you want to skip ahead, I'll go ahead and answer these. I'll work them out really fast. So y equals x plus 2. So x equals y plus 2. So minus 2 from both sides. So y equals x minus 2. You got this one. I'm going to go quick through these just because they're the same process. So g of x here. So y equals negative 1/3 x plus 3. Let's switcheroo. All right, now I need to go ahead and isolate this. So subtract 3 from both sides. All right, now what you need to do here is I need to divide everything by negative 1/3. That is the same thing as multiplying by the reciprocal. So instead of dividing by negative 1/3, I'm going to multiply, flip negative 1/3, you get negative 3. So that's the big boy way to do it, the big kid, big boy, big girl way to do it. You are dividing by negative 1/3, but when you divide by a fraction, remember your good old friend, keep, change, flip. So that gives me negative 3 times x minus 3 is equal to y. So I can simplify this. So negative 3x plus 9 is equal to y. So this was g. And you got your answer here. So remember that if you're dividing by a fraction, remember your old friend, keep, change, flip. And that's an easier way to do it. All right, last two. H of x, so y equals 7 minus x. So x equals 7 minus y. Subtract 7 from both sides, so x minus 7. A lot of people will forget this negative y. So make sure you keep it there. Divide everything by negative 1, so you're changing these signs. So negative x plus 7. So h, whatever. And you got your answer, negative x plus 7. All right, the last one. So I have y equals x plus 5 over 8. So therefore x equals y plus 5 over 8. Oh, that's an 8. All right. So remember, I'm going to put that over 1. That's cross multiply. So 8x equals y plus 5. Subtract 5 from both sides. So 8x minus 5, and then rewrite it. So g inverse of x equals 8x minus 5. So big things here. We are switching our x's and y's and solving for y. That's how we're finding our inverses. If we are using a graph or a chart, all we're doing is flipping our x's and y's. If we're graphing something, same thing. Get your new points, flip your X's and Y's, plot those points down. It is a reflection over the line y equals X. And that's a quick way to check it. Switch X and Y and solve for Y when we're finding them. Please make sure you're using the proper order of operations to keep things straight. So if you got any questions, let me know. There is a practice today. Make sure you're practicing walking through it, getting as much done as possible. Check your solutions. If you have questions, please let me know. Other than that, hope you have a wonderful day, and I will talk to you soon.